Okay, so as promised, I'm going to walk you through how I would have approached that Fermi problem we were doing in breakout rooms. I apologize that we didn't time it well and I didn't have time to do this in class, but I wanted to show you kind of my thinking and show you a way to do this without really having to look anything up or use a calculator. Okay, so we're trying to find the total mass of the Earth's oceans. Okay, so the first thing I'm going to do is I'm going to kind of think about how to approach this problem. Well, what do I know about the oceans? Well, I know the oceans are made of water, and a number I do know is the density of water. So the density of water is approximately 10 to the third kilograms per cubic meter. Okay, that happens to be a number I know. As you do more of these problems, there will be numbers like that you start to kind of just know. So the density can actually help us find the mass, because the relationship between density and mass is that density equals mass divided by volume. Okay, so if we knew the volume, we can actually find this mass, because if we rearrange this equation, that mass is going to equal density times volume. So for me, I think a good approach would be to attempt to find this volume of the oceans on Earth and then use the density to find the mass. Okay, so to find the volume, okay, well, let's think about Earth and finding the volume of the ocean. So I could find the volume of the Earth by taking 4/3 pi r cubed. But the oceans, if we think about where the oceans are like just minuscule depth compared to the actual depth of the Earth, or like the diameter of the Earth. So it's just a skinny little top. So that looks like all the way around too. But it's hard to draw in 3 dimensions. But yeah, that's just a really skinny little bit at the top. So that's looking more like almost a surface area type calculation for the Earth. And then we can multiply it if we knew the depth of the ocean. Okay, so if we can find the surface area, okay, or just area of the Earth, okay, and multiply it by the depth of the ocean. So if we were to think about the surface area of the Earth, if we were to it's hard to flatten that shape, but if we were to flatten that all out, that the surface area of the Earth, cut it up so that we could flatten it out, and then multiply by the depth of the oceans on average, we would end up with that volume that we're looking for. Okay, so my plan is to take the surface area of the Earth and multiply it by the depths of the oceans. Oh, I called surface area of the Earth a subscript E. Okay, so I'm going to take to find the volume of the Earth, I'm going to take the surface area of Earth times the average depths of the ocean. Okay, I don't know those values right now, but I think I maybe know enough to be able to kind of figure out about what they might be. The area of the Earth, well, is the whole Earth covered by ocean? Well, no, but a lot of it is. So I'm gonna maybe say 70% of the area of the Earth times that depth is going to be the volume of the ocean. Okay, so I'm going to take 0.7 times AE, or the area of the Earth, this times the depth. Okay, so now I have a plan. Okay, to find the volume, though, I need the surface area of the Earth. So surface area of a sphere is found by taking 4 pi r squared. Okay. I can also rewrite that, actually, because 4 is 2 to the power of 2. I can combine the 2 squared and the r squared to 2r squared times pi, and it's pi times the diameter of the Earth squared. Okay? So, diameter of the Earth. Well, I actually gave you this value in class. I'm going to scroll down, so you might lose a little bit at the top, but we'll come back to it. So diameter of the Earth. Well, the diameter of the Earth is about, oh, that's terrible, is about 10 to the 7th meters. Okay, so I'm going to take, to find the area of the Earth, I'm going to take pi, which is about 3. Again, this is all approximate. So I'm going to take 3 because that's easier to do math in my head with a 3. Times 10 to the 7th squared. Okay. Okay, so when I take 10 to the 7th squared, I multiply 7 times 2, so 10 to the 14th times 3 equals the area of the Earth in square meters. Okay. Okay, cool. Well, here in my volume calculation up here, I said I just wanted 70% of the area of the Earth. Okay, so we have, so far, in our equation to find the volume, we're going to take 0.7 times 3 times 10 to the 14th. Okay, so that comes from the 70%, that gave me 0.7, the 3 came from here, and the 10 to the 14th came from right there. I don't know why I switched to parentheses. I'll switch back to the multiplication dot. Okay, so now we're just left with needing, we can't forget this, depth, because our volume of the Earth times the depth of the ocean. So we have the surface area of the Earth times the depth of the ocean. And this specifically is the surface area of just the oceans on Earth. Okay, I missaid that. So we have the surface area of the Earth times 0.7 to give us the surface area of the oceans, an approximation. And now we're going to multiply by what we think the average depth of the ocean is. Okay, so depth. Well, let's think about that. I teach physical science, and we talk about this a little bit, and like the Marianas Trench and Challenger Deep, those are a little over 10 kilometers. Okay, and the rest of the ocean, though, is more than a kilometer deep, but it's probably close to a kilometer than 10 kilometers. So what we're going to do, we're kind of going to bound this and think about what would be a good number to use. So 1,000, so 10 to the 3 meters, we think is less than the average open ocean depth. But we know that the average ocean depth is quite a bit smaller than those really deep ocean trenches. So let's maybe use a value of like 3 times 10 to the 3rd as our approximation for the depth of the ocean on average. Okay. Again, I'm kind of just, like eyeballing it. And I guess I'm not looking at it, but I know that the deepest parts of the ocean are 10 to the 4 meters. Most of the ocean is probably more than a kilometer deep. So we're definitely closer, though. There's not as many there's not a ton of trenches in really deep spots. So I just went a little bit closer to 10 to the 3rd than 10 to the 4th. So I got 3 times 10 to the 3rd. That's about, on average, I'm going to say 3,000 meters. If you look it up, it's actually 3,600 meters. But we don't really care about the actual numbers. We're trying to just ballpark. Okay. So now we have a big, long string of numbers we can put together. So 0.7 times 3 times 10 to the 14th times 3 times 10 to the 3rd. Okay, so we got that 3 times 10 to the 3rd from the depth of the ocean. This 3 times 10 to the 14th is the surface area of the Earth, and we multiplied that 0.7 by 0.7 because we just wanted the surface area of the ocean. Okay, so now this is something I can do in my head. I don't need a calculator for this. So we get 2.1 if we multiply 0.7 times 3. And then if we multiply 2.1 times 3, that'll end up being 6.3. Okay, and then we have still a factor of 10 to the 14 times 10 to the 3rd. Well, I can combine those, right, by adding 14 plus 3. When I have a power of 10 to a certain exponent, you add the exponents. So I have 6.3 times 10 to the 17th. Okay, so there is my volume estimation. okay, for the volume of the ocean. So we got there. It took a little bit, but we got there, and we can be fairly certain that it's going to be somewhere around there. Well, now we don't really need 2 decimal places, so we're just going to say it's about 6 times 10 to the 17. Okay? Well, heck, we're just caring about order of magnitude, so 6 times 10 to the 17th is closer to 10 to the 18th, so let's just care about order of magnitude, and we can say it's about 10 to the 18. Okay, so let's head back on up because we're not quite done. That's our estimate for the volume, but we said that in order to find the mass, we need to take the density, which we said was 10 to the third, times the volume, which we just estimated as 10 to the 18th. Okay, so let's check out the units here. 10 to the third is kilograms per cubic meter. Okay, down here we had, well, this part right here, well, no, sorry, not right there. If we take this part right here, that had the units of meters squared. Right here, this 10 to the 3, or 10 times 10 to the 3, had the units of meters. So this is meters cubed. Okay, so when we go up here and we multiply 10 to the third times 10 to the 18th cubic meters, our meters cancel out, and we end up with an answer as expected in kilograms. Okay, so our approximation, I shouldn't put an equal sign because we're just guessing, right? Making our best guess. So 10 to the 3 times 10 to the 18th, you're going to add the exponents. We're going to estimate that the mass of the oceans on Earth are approximately on the order of 10 to the 21 kilograms.